This is application integration paper 2, so you can use your calculator. So the first part, find the value of k. So this is interesting. Do you need to use factor theorem to factorize this? Actually, no. Although it's a cubic function, right? You can actually take out your x. Okay, we'll do this here. At x-axis, y is 0. When my y is 0, you will get, some people write k0, substitute k0 also can. You will get 6x squared minus 9x minus x power 3, let it be 0. I'm going to transfer everything to the right. I'll get x cubed minus 6x squared plus 9x equals 0. I'm going to factorize my x, left with x squared minus 6x plus 9 equals 0. So from here, we can actually factorize this to x minus 3 bracket square. So the roots are 0 and 3. But since you're finding k, right, your k is obviously non-zero. So therefore, k is what? K is 3. K is your x-intercept. Yeah, so happen it touches the x-axis at 1 point. Now, next, calculate the area bounded by the curve and x-axis. Okay, area bounded by the curve and x-axis is basically this. Okay, you can highlight the curve. Looks like this. X-axis is this. So the region is this. Okay, now, but you need to either put the negative or modulus because the area is negative. Area is below, so area can't be negative, so you modulus it. The integration value can be negative. You either modulus or you put a negative in front. Your limit is from 0 to 3, 6x squared minus 9x minus x cubed dx. Okay, so when I integrate, I like to do a bit faster. I copy x, increase the power by 1, 3, 6 divided by 3 is 2. This is 9, copy x, increase the power by 1, 2, divide by the increased power 2. This is x power 4, divide by the increased power 0 to 3. So let's put inside. This is 2, 3 power 3, 27, 9 over 2, 3 power 2 is 9, 3 power 4, 81, minus 0. So now you notice the number is bigger. So you are allowed to use calculator. Usually bigger number we put in calculator paper. So 2 times 27, this one is 81 over 2. Then you minus 81 over 4. Okay, my answer is negative. Why negative? Because it's below, right? So that's why I put the negative in front, right? Negative 27 over 4. You can write 27 over 4. You can even write in mixed number. Mixed number would be 6, 3 over 4. Okay, square unit. Okay, again, you know you can use your calculator to counter check out. You can use integration 6 alpha x squared minus 9. Your x is alpha x. If you're using new calculator, x is above here. So you minus x cubed. This will be from 0 to 3. And my answer is this 27 over 4. I know it's correct. Yeah. All right, question number 2. Given an area enclosed by this curve, x-axis, x equals to ln 2, x equals to ln a, where a is more than 2 is, okay, so there's a double is here, is 63, find over a. Okay, so we know, now the curve probably look like this. If you don't know how it looks like, it's fine. Now this is an exponential, so it should be going up like this. What matters is your limit, x equals to ln 2, x equals to ln a. This is your x-axis, so this is your region, right? So we should integrate from ln 2 to ln a. Your function is 6e power 2x dx. Your area is 63. So when you integrate, you're going to divide. 6 divided by 2, copy e to x, right? You can leave the 6 over 2 outside. Ln 2 on top, or below ln a on top, the result is 63. Now this 6 divided by 2 is 3, you can divide it. On the right hand side becomes 21. Sub ln a inside, so it's 2 ln a, e power 2 ln a, right? Minus e power 2 ln 2. Okay, now remember, e power n ln x is x power n. So in this case, this will be what? A power 2. Second one will be 2 power 2. The result is 21. 2 power 2 is 4. Bring over 4 plus 21 is 25. A should be what? Square root of 25? 5. Now, you don't need to put plus, minus, don't put negative, because what the question we mentioned, A is more than 2, so A is just 5. Question number 3 is a combination of area of triangle. This is a triangle. You move down, this is 2, right? This is 3, right? Plus area integration. So area triangle is half times base times height. Your base is 2, your height is 3. Area integration is from 2 to 3. Your function 12 over 3x minus 2 dx. The first one is going to give us 3. Second one, going to use ln. Okay, remember, integration of 1 over ax plus b dx will give us 1 over a ln ax plus b. Remember this formula? So we're going to divide by a. So we write this as positive 12. I take it out, divide by 3 of ln 3x minus 2, lower limit 2, upper limit 3. So 12 divided by 3 is 4. Let me substitute 3 inside. 3 times 3, you can write 9 actually straight away. And then 3 times 2. Okay, so this is 3 plus 4. 9 minus 2 is 7. 6 minus 2 is 4. Okay, so can we simplify this? Yeah, the number is a bit ugly, but they say exact area. So we leave it in exact form. So number 1, I think I can combine this to 7 over 4. In logarithm, minus combine becomes divide. Then number 2, I just keep the 4 in front. Don't need to do anything. This will be your area in square unit. Question number 4 also involving ln. You notice that there's a straight line that cut across here. This one is actually a trapezium. This is 2. This is 8. This is 4. This is 10. So you want to use a trapezium here with the measurement. This one is 8. This is 10. This is 2. Then you minus area of integration. Your integration is from 2 to 4. So let us start. Area of trapezium, half sum of parallel side times height minus integration 2 to 4. Your function is 2x plus 8 over x dx. So 2 and 2 can cancel. This is 18, right? 18 here. When you integrate this, integrate 2x, you get x squared. Integrate 8 over x, this gives us 8 ln x. Remember, integration of 1 over x is just ln x. Yeah, plus c. Okay, the lower limit is 2, upper limit is 4. So let us substitute. Put 4 inside. 4 square is 16. 8 ln 4 minus 2 square is 4. 8 ln 2. So that's 18 minus 16. Okay, this ln 4, right? I want to simplify it. The negative I times inside is 8. Ln 4 is 2 ln 2. How we know? Because 4 itself is 2 power 2. The power 2 you bring in front is 2 ln 2. Then you have a double negative, becomes a positive 4. Then the double negative cancel out, another positive 8 ln 2. Now your 18 minus 16 is 2. 2 plus 4 gives us 6. This is minus 16 plus 8 of ln 2 is minus 8 ln 2. So your final answer is 6 minus 8 ln 2 square unit. This question a bit unique. You're finding the value of unknown k, given that the area of shaded region is 1 over 3. So your shaded region actually consists of this integration minus this triangle. So for integration, right, I'm going to integrate from 0 to k. My function is 3x minus x squared dx. For area triangle, I take half times base times height. Now here's the thing, what's your base? Your base is k. But how do you find your height? You need to sub in x with k. Your answer will be in terms of k. If you sub k inside, let's say if your x is k, what's your y? Your y will be 3k minus k squared. So this is 3k minus k squared. This is the height of your triangle. So your base is k, height is 3k minus k squared. The result is 1 over 3. So let's integrate this. This will give us 3x squared over 2 minus x cubed over 3. Limit is from 0 to k. So I can times it 1 by 1. I'll get negative 1 over 3. Sorry, negative 3 over 2. Not 1 over 3. The 2 and 3. 1 over 2 times 3k is 3 over 2k. Minus plus 1 over 2. K times k squared is k cubed. The result, you can write this as improper fraction 4 over 3. Now, let's substitute k inside. This is 3 over 2k squared minus, I'm going to write 1 over 3 first, k cubed. 0, I sub inside. The whole thing is still going to be 0. Then you copy the rest of this. Is k squared. Sorry, there's a k squared here. And notice this two you can cancel. I can cancel this two. I'm left with negative 1 over 3. And I plus with 1 over 2. So 1 over 2 minus 1 over 3 is 1 over 6. You can't do mentally, use a calculator. 1 over 6k cubed is 4 over 3. 6 times 4, 24. 24 divided by 3 is 8. Cube root of 8k is 2. Question number 6. The first part, you find the x-intercept, which represent A. A is your x-intercept. Now we know at x-axis, y is 0. So x-axis, y 0. So we take 1 minus 3e power negative x, let it be 0. Bring it over. This one is equals, divide by 3, 1 over 3. So you change from exponential to logarithm. So this is ln 1 over 3. But ln 1 3 is simply ln 3 power negative 1. The negative 1 I bring in front. So what's your x? Your x is ln 3. The x value is actually your A. So my A is ln 3. Alright, next, show that the area shaded region is given by this. Okay, area shaded region consists of two parts. One left is below. So when you calculate your area, you need to put a negative. You put negative or modulus because the integration value can be negative, but area is always positive, right? You put negative or you put a modulus. I prefer to put negative. You can put modulus if you want. Your limit, your A is now ln 3. So I sub in, this is ln 3. E power negative x dx. The second part is positive because it's above the x-axis. You start from ln 3, you move on to 2, 1 minus 3e negative x dx. Okay, as I integrate 1, I get x. Integrate this, negative 3 divided negative 1 is positive 3e negative x. Lower limit 0, upper limit ln 3. This is the same, x minus become plus 3e negative x. Lower limit ln 3, upper limit 2. Let us substitute inside. This is ln 3 plus 3e minus ln 3 minus 0 plus 3e power 0. Okay, keep adding. 2 plus 3e minus 2 minus ln 3 plus 3e minus ln 3. Very long, huh? Okay, actually the second one, no need to put bracket. I don't want to put this bracket. Yeah, leave it up. First part, I need to put a negative and a bracket. So this is minus ln 3. And remember, as I said earlier, e power n ln x is x power n. This is actually 3 power negative 1. So 3 power negative 1 is 1 over 3. If you're not sure, you can use the calculator. Now there's a double negative here, so it becomes positive 3. Yeah, this one is 3. Yeah? Double negative becomes positive. Copy your 2 plus 3e minus 2, followed by minus ln 3, minus another 3 here, with a 1 over 3. Now, notice these two I can put together. I can do a bit slower here. I take these two, add together. This is going to give us minus 2 ln 3. Alright? You can think of this as negative 1. This one you can plus together, plus 5. There is another 3. With the e power negative 2, I can bring it down. Ln 3 already combined, another minus 1. So you're left with 5 minus 2 minus 2, minus 1, which gives us 3. Okay, let me highlight for you. Your 5, you must minus 1 minus another 1. That gives us 3, followed by 3 over e squared, followed by 2 ln 3. There you go. That's your area. So here we're finding the value of unknown here. We are given y equals 4 sine 2x plus pi over 6. Okay, first we sub in your x with pi over 3, your y with k. We're finding k. Your k is your y value, which is 4 sine 2 times x pi over 3 plus another pi over 6. Okay, 2 over 3 plus 1 over 6. If you can't do mentally, you can use a calculator. 2 over 3 plus 1 over 6. That gives us 5 over 6. So this is 4 sine 5 over 6 pi. Sine 5 over 6 is sine 150. Sine 150 is actually 1 over 2. You can use your calculator if you're unsure. Sine, just make sure to change your calculator to radian mode, right? 5 over 6 pi is going to give us half. So answer is 2. Your k is just 2. Meaning I draw this line here. This is pi over 3. This is 2. We're going to use area of integration minus area of triangle. So this is your integration here. Then I minus triangle. Okay, area integration, you can integrate from 0 to pi over 3. Your function is 4 sine 2x plus pi over 6 dx. Area triangle is half times base times height. Your height is 2. So when you integrate sine, you should get cos, but there's a 2 here. So you need to take 4 divided by 2, and there's a negative. Integrate sine is negative cos. You are left with a cos of 2x plus pi over 6. Your limit is from 0 to pi over 3. Then this can cancel, is pi over 3 itself. Let us simplify. Negative 2 sub inside cos. Let me write 2 pi over 3 area plus another pi over 6. If you substitute the second time, 2 times 0 is 0 plus pi over 6. Then you minus pi over 3. This will give us negative 2 of cos 5 over 6 pi minus cos 0. This is pi over 3, pi over 6. Okay, actually you don't have to put a bracket. Pi over 6 equals, minus pi over 3. So cos 5 pi over 6 is cos 150 is negative sec 3 over 2. If you're not sure, just use your calculator. Let me just change this to cos. Yeah, negative sec 3 over 2. So this is negative sec 3 over 2. Cos of pi over 6 is positive sec 3 over 2. Then you minus pi over 3. So this one you add together is just sec 3. Negative times negative is positive. So it's 2 sec 3 minus pi over 3. Yeah. Answer a bit annoying. Yeah. But they say exact area. Exact area means you don't change the decimal, leave it in sec form or pi form. So this one involving differentiation integration, because you cannot integrate tangent directly. You can integrate secant square to get tangent, but you cannot integrate tangent. So at least not at your level. So that's why we have to use the differentiation part first. So here we're differentiating ln of cos 2x. Okay, remember the basic or the fundamental is that when you differentiate ln fx, what do? You copy your fx below, differentiate, put it on top. So likewise, I copy my cos 2x below, differentiate cos 2x, you get negative 2 sine 2x. Remember, differentiate cos is negative sine, but there's a 2 here, so you go to times 2. Okay, this is your fx. This is your fx. You copy your fx below, this is your fx. The one on top is your f prime x. Okay, I'm using this formula for differentiating ln. So be interesting. Some people change it to tangent. Okay, I think I changed to tangent because you see you got to give your answer in tangent. Later the graph is in tangent. Right? We know sine over cos is tangent, right? So guys, I'm going to change this to tangent. Okay, this is negative 2 tangent 2x. Okay, next I'm going to use the result to solve this, because when you differentiate the red one, you get, let's say, the green one. And if I integrate the green one, negative 2 tangent 2x dx, you get back the red one, which is ln of cos 2x plus c. Right. Now, I now need to divide by negative 2 because I need to use this result. See this? Integrate tangent 2x dx. Divide by 2 is negative half of ln cos 2x plus c. This is without limit. The question actually gave us the limit. The limit is from 0 to p. And after you integrate, this area will give us a ln of sec 2. This area is already given. So you're going to use this information, sub in the result of integration, and next we need to sub in the limit. So we can find unknown p. So this negative half, I can take it out. You can even times it over. I take it out first. So let's write ln of cos 2b minus ln of cos 0. This is cos, a bit ugly. Maybe I write cos 0 like this, ln set 2. Okay, well, what can I do with the negative half? A bit annoying, right? You can actually bring this down, okay? Maybe I bring it down here. I don't write so many steps, guys. I bring this down so I can cancel it. This is half ln 2. And from here, I'm going to cancel my half and half, okay? Negative here, I can keep it first. This is, you can combine this to ln, copy your ln first of cos is ugly, cos 2b. What is ln 0? Ln cos 0. Cos 0 is 1. So this is going to give us 0. Ln 1 is 0. So it's ln cos 2b followed by negative ln 2. The negative ln 2 I bring up. So it's ln half. Wow, very long. Now with that we can compare. Cos 2b is now half change from, we inverse ln, inverse cos. We want to change, find your reference angle. This is in radian, pi over 3. So 2p is pi over 3. Now, you don't have to go and find the reference angle, then minus. You know why? Because there's only one answer. This is quadrant 1. So what's your p? Pi over 3, you divide by 2, pi over 6. p is pi over 6. Diagram shows part of the curve y equals secant square x over 3 minus 1 and a horizontal line y equals 1. So they intersect each other at point P. So find coordinate point P. Okay, very simple. At point P, we can call this equation 1, equation 2. Basically, we sub 2 in 1 or 1 in 2. So you get 1 equals to secant square x over 3 minus 1. Bring it over. Secant square x over 3 is 2. Secant square is 1 over cos. So I'm going to invert both sides. I hope you all can do this. Invert the left, you get cos square. Invert the right, you get 1 and 2. Because secant square is 1 over cos square. So I invert. This one becomes cos square. 2 means 2 over 1. You invert, becomes 1 over 2. Yeah, switch upside down. If you want to write one extra step, go okay. You can write secant change to 1 over cos square first. Then only you switch or invert both sides. Now, from here, I need to square root. When you square root, always put a plus minus. But I think no need to put plus minus here because it's positive, right? You can see it's on the right-hand side. Positive. Only one value, right? Okay, this is the acute angle. So you don't need to do both. Yeah, it's not like it has another quadrant and all that. So use your calculator. This one have to use calculator. Shift cos 1 over sec 2. It will be pi over 4. Pi over 4. So you can write 1 x over 2 is pi over 4. When you times 2, x is pi over 2. So your coordinate of point P is pi over 2 and 1. You write your x followed by your y. Okay, your x is pi over 2, your y is 1. Now next, find in terms of pi the area shaded region. Okay, this one we use rectangle minus integration. This is a rectangle. You minus this integration. So for rectangle, very easy. You can see is pi over 2 times 1. For integration, we integrate from 0 to pi over 2. Your function is secant square x over 3 minus 1 dx. This will give us pi over 2. Integrate secant square is tangent square, but be careful, there's a 1 over 3 here. So it's 1 divide 1 over 3. This is over 3. Yeah, no wonder. This is over 3. So it's 3 over 4, right? So yeah, 3 over 4 pi. So your limit has to change from 0 to 3 over 4 pi. This is 3 over 4. So when you subtract, this one will be, when you integrate secant square, this is 3 over 4, 3 over 4. Okay, integrate secant square is 1 over tangent. It's just tangent. So this is 1 over 3. So I write a tangent with the x over 3. Integrate 1 is x, lower limit 0, upper limit 3 pi over 4. Okay, I'm going to simplify further. 3 pi over 4. This one 3. I'm going to keep this first. 3 tangent. I'm going to substitute 3 pi over 4 inside. Okay, so there's a 1 over 3 here. Maybe we cut short a bit. 1 over 3 of 3 pi over 4 is going to give us pi over 4. Then you minus, x is 3 pi over 4. Minus again, this is 3. Put 0 inside x is tangent 0. There's another 0 here. So this is going to give us 3 over 4 pi. And tangent, this one is tangent pi over 4. Tangent pi over 4 is tangent 45. Tangent 45 is 1. Let me put a bracket here. This is 1. 3 pi over 4. Tangent 0 is 0. Right. So simplify this. Minus minus is plus. 3 over 4 plus 3 over 4 is 6 over 4. 6 over 4 is 3 over 2 pi minus 3. So your area is in square unit. So given diagram shows part of the curve y equals x e power 1 over 2x. So first part, find the differentiation part. So we differentiate dy dx or d dx. Copy your e x e power half x. So this is your uv. So this is your u. This is your v. When you differentiate, you copy u, differentiate v, differentiate u, copy your v. So I'm going to write down my u, which is x, differentiate e power half x is a half e power half x. Differentiate u, you get 1, copy e power half x. So this is going to give us half x, e power half x plus e power half x. Okay, so the first part we're supposed to differentiate. Second part, we're going to use the result. We say, hence find the integration of this. Now remember, we've done this many times. Differentiate the red one, gives us the green one. Integrate the green one. Your green one is half with the x e power half x plus e power half x dx. Gives us the red one. Red one is what? X of e power half x plus c. Now I'm going to split them into 2. So you can take out half here with the x e power half x dx. This one we can integrate. When you integrate this, it's going to be 1 over half of e power half x. This is x of e power half x plus c. I'm going to transfer this to the right hand side. Keep your half x e power half x dx. This one is possible, bring over, becomes negative. So it's a x e power half x minus 2 e power half x plus c. Lastly, I multiply by 2. As I multiply by 2, I get 2x e power half x minus 4 e power half x plus c. Yeah, it's very, very long. The c you don't have times 2. A c is a constant, arbitrary constant that we do not know the exact value. If you times 2, you get the same, another constant, just call it c again. Alright, now next we're going to use the result to find area bounded by the curve. Okay, where's the curve? This is the curve. X-axis, this is my x-axis. Straight line x equals 2. Maybe x equals 2 is here. So the region is actually here. I just use a different color. This one. Okay, so you don't even have to sketch, just to identify the limit. So your area will be integration from 0 to 2 of x e power half x dx. Now we're going to use this result from part B to find the area to integrate us. So this is 2x e power half x minus 4 e power half x. Lower limit 0, upper limit is 2. I'm going to put 2 inside. 2 times 2, e power half times 2 is 1. Half times 2 again, 1. Put 0 inside. Now 0 times anything is still 0. Second one, e power 0. So this is going to be 4e minus 4e. Okay, let me write 4e minus 4e, which is 0. Then minus minus, this is 0 itself, plus 1. So your area is just 4, right? 4 square unit. In the level, you have 2 curves. The first one is y equals square root x. Second one is y equals 6 over square root x minus 1. So you're finding the coordinate x coordinate point P. So coordinate point P is the intersection between these two graphs. So we can first sub 1 in 2 or 2 in 1, square root x equals to 6 over square root x minus 1. Here, if you can't see, right, may I suggest you use substitution. You let square root x becomes u, because some people cannot see that. It's like what we call a disguised quadratic equation. When you replace x with u, this becomes 6 over u minus 1. Multiply everybody by u square equals to 6 minus u. Bring it over, u square plus u minus 6 equals 0. We solve for u first. Double bracket factorize. U and u. 3 and 2. Plus and minus. My u is either 2 or negative 3. Now remember, u is your square root x, right? You cannot square root a number and get negative. That's why you have to ignore negative 3. Only take square root x equals 2. And when I square it, x is 4. Now, do you put plus minus? No. Why? You can only square root 4 and get 2. You cannot square root negative 4 and get 2. This is impossible. You can't square root any negative number. It has to be positive. So here your x is just 4. Meaning my coordinate here is 4. Okay, the x coordinate of point P. Next, I need to find area. So area has two parts. The first part, you integrate the first function from 0 to 4. Your function is square root x dx. Second part, I need to integrate this. The second graph here is from 4 to 36, 6 over square root x minus 1 dx. Now, integrating square root a bit hard, so I would change it to general form first, which is power half. Okay, second one, 4 to 36, I bring it up, 6x power negative half minus 1. So when I integrate, I copy x, increase the power by 1, half plus 1 is 3 over 2, divide by 3 over 2. Lower limit 0, upper limit 4. Okay, second one, copy 6, copy x, increase the power by 1, minus half plus 1 is half, divide by half, this is x, lower limit 4, upper limit 36. So you want to take this and flip upside down. This is 2 over 3. Let us put 4 inside, 4 power 3 over 2, minus 0. 0 power anything is still 0. This one I'm going to flip upside down, becomes 12, square root x, I'm going to put 36 inside, minus 36, another time, 12, square root 4, minus 4. Okay, it's very long. Huh? Now, okay, let me move on a bit. We know 4 power 3 over 2 means square root 4. For square root 4 is 2. 2 power 3 is 8. 8 times 2, 16. Okay, next one, plus 12 times square root 36. 12 times 6. 12, 6 is 96. You minus 36. Okay, then you have a minus 12 times 2 is 24. Minus plus 1 more 4. You can use a calculator. You don't have to like count manually like what I did here. Okay, let me just use a calculator for the last part. 96 minus 36 is 60. You minus 24, then you plus 1 more 4. You should get 40. You plus, okay, this is 16 over 3 plus 40. Yeah, you can use mixed number, improper fraction, doesn't matter. So I got 136 over 3. Okay, sorry, 12, 6, not 96, 12, 6, 72. Yeah. I count this wrongly mentally, 72. So this is 72. 72, you minus 36 is 36. 36 minus 24 is 12. 12 plus 4, 16. So it's 16 over 3 plus another 16. That will be 64 over 3. Or you can change to mixed number, 21, 1 over 3. Yeah, this is square. Question number 12. Diagram shows straight line y equals x plus 5 intersecting the curve y equals x minus 1 squared at point A and B. So find the x coordinate. So we know first part we have to solve them simultaneously. Call this equation 1, call this equation 2. You can sub 1 in 2 or 2 in 1. Doesn't matter. Huh? We write x minus 1 squared equals to x plus 5. Expand the bracket. X squared minus 2x plus 1 equals x plus 5. Bring it over, x squared minus 3x minus 4 equals 0. So what's the factor of 4? We use 4 and 1, okay, minus and plus. So your x values are -1 and positive 4. This is -1. This is positive 4. This one is 1. How do I know this is 1? At x-axis y0. You can let y be 0 and find x. But actually, that is not important. What we want is the x-coordinate. Your x-coordinate is of point A is -1. X-coordinate of point B is just 4. And if you want to find the area of shaded region, we should take area of trapezium minus area of integration. See, when you integrate, right, you're actually getting this region here, this part here. Yeah? If you integrate the curve, you're getting this part here. But we're not finding this yellow part. You're finding the shaded region. The shaded region, you need to take trapezium minus the yellow part, the integration. Okay? So, okay, I should erase this. So it looks like this. Now, your trapezium, we already know this measurement. If you measure from here to here, 4 minus minus 1 is 5. Your y value you need to find. Okay? We need to find your y value. Okay? When your x is -1, what's your y? You can sub inside equation 1 or equation 2. I like equation 2 because it's easier. This is 4. So your x-coordinate point A is 4. Your y-coordinate, not x-coordinate. So when the x is 4, your y is 4 plus 5. Answer is 9. So your y-coordinate point B is 9. So this is from 4 to 9. Okay? And your limit here is from -1 to 4. So to calculate your area, this is part A, this is part B. To calculate your area, we take area of trapezium, which is half sum of parallel side times height, minus area integration, -1 to 4. Your function is x minus 1 square dx. Okay, so 4 plus 9 is 13. 13 times 5 is 65, right? Yeah, divide by 2. Okay, for the second part here, I need to use integration of composite function, copy the bracket, increase the power by 1, 3, divide by 3, differentiate inside the bracket 1, lower limit -1, upper limit is 4. So let's simplify further. I'm going to take out 1 over 3, sub in 4, 4 minus 1 cube, -1 minus 1 cube. Okay, so 65 over 2. This is 1 over 3. You can use your calculator to do this. I don't want to do one by one. This is 4 minus 1 is 3. 3 power 3, 27. 27 minus 8. -2 power 3 is -8. So that will give us 35 over 3. So it's 65 over 2, 35 over 3. Okay. Now, before I move on, I just want to double check. I don't know whether my integration is correct. So I'm going to put x minus 1. I'm going to square it. My limit is from -1 to 4. I press equals. I should get 35 here, which is correct. Yep. So take this. I take 65 over 2 and I minus this answer. 125 over 6. 125 over 6. Or you can change the mixed number. Normally improper fraction is good. Our marking scheme usually just give improper fraction. But I personally like to use mixed number because mixed number tell me that the area is what, in this case, 20 and a bit more is less than 21. Okay. If this video helped you, you can get my advanced book from Shopee or Lazada or by searching teliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Teliti. Remember to like, subscribe, and share. See you in the next video.